Hello and welcome to this podcast for Electropages. My name is Robin Mitchell and today I am joined by a special guest, Chet Babla from Semiconductor. And all I'd like to say is thank you for being here today.
Absolute pleasure to be with you, Robin. Thank you.
Before we get into the nitty gritty of this podcast, the first thing I'd like to ask you is could you just introduce yourself to the audience, who you are, what you do, and what you do in your free time?
So my name is Chet Babla. I'm the Senior Vice President of Strategic Marketing at Semiconductor. That covers all matter of ills, but broadly looking at new market segments, new product strategies, supporting some of the mergers and acquisition activity that the company does, and also looking after some of the corporate marketing as well. So kind of broadly, that's where I focus. I love automotive, as you might be able to see behind my shoulder there, Formula One.
Absolutely.
And in my free time, apart from watching Formula One and following it avidly, I love cycling, road biking, mountain biking, and keeping fit in general.
So to me, it sounds like anything that involves wheels.
Generally, I think that's fair. Yeah, I forgot to mention motorcycling as well.
So definitely a gearhead for sure. So I must ask you, what's your qualification in then? Is it to do with automotive or is it engineering in general?
Yeah, so I studied electrical and electronic engineering, but after graduating at university, I went into the semiconductor industry. So I was a RF and analog chip designer, and I've been in semiconductors for 30 plus years.
I think it's fair to say that most engineers will agree with me when they say that people who deal with analog and RF systems, it's almost a black magic. It's very much like witchcraft to me. None of it ever makes sense. You know, you design a radio circuit, it doesn't work for some bizarre reason, and it takes a genius like someone like you to come along and figure out all the issues. So when did this interest for cars then step in? Because I would have assumed that if you enjoy cars and vehicles so much, you would have gone into mechanical engineering or automotive.
Yeah, no, I think I was always interested in cars from a young age, like perhaps many young kids. My model cars, Matchbox cars, if you remember those.
Hot Wheels.
And my father was really into cars. We had the Mark I Escort and Cortinas. So I think from a young age, I was kind of exposed to it. But actually at school, at college, it was the electronic side that interested me. So hence the kind of semiconductors angle.
Oh, absolutely fantastic. But the first question I'd like to ask you is, what is it that you would like to present today on this podcast?
Yeah, so really I wanted to introduce to the listeners, to the viewers, Semiconductor. Perhaps we're not quite a household name like other semiconductor companies. We're, California headquartered, NASDAQ listed, fabulous semiconductor company focused solely on the automotive market segment. The reason we're focused on automotive is we see so much innovation happening in the space. When I started many years ago as a chip designer, actually no one wanted to work in automotive because it was seen as the boring end of electronics. And if you fast forward, 15, 20 years, there's so much innovation happening across multiple areas in automotive that, it's a great place to be if you're in tech. So, whether it's driver safety or electrification of drivetrains, or the in-cabin user experience, all of those areas are seeing so much growth and innovation. So it was just an opportunity really to talk about some of what we're seeing as we engage the market and what Indie is focused on to try and help end customers innovate in that space.
So I think a good question to ask you then is, what's the biggest change that you've seen in the automotive industry over the past sort of 20 years?
Oh yeah, great question. I think safety really has been a huge inflection point in the industry. I can remember when seatbelts were first introduced into the UK, right? And everyone was up in arms. Why do I have to wear
a little bit old?
Yeah. So, when they became mandatory. But we've come a long way since then. We've got, vehicles are packed with sensors now. If you look, radars, cameras, front camera, back camera, ultrasonic. We're even seeing LiDARs being introduced. And, these innovations are saving lives today. So I think from a, saving people's lives absolutely has to be the driver safety innovation that's happening in automotive.
And I think it would also be fair to say that not only as safety as being a critical factor in driving in general, but I think it's also fair to say that when it comes to vehicles, it's almost like that they're more electronic than they are mechanical, especially with the move towards EV. What would you say about that?
Yeah, absolutely. I think, as we move towards a world of electrification, and there's, very important mandates for that around climate change, government regulation, better consumer awareness, all of the electronic architectures for cars are being redesigned. And that's become an incredible opportunity, really, for vehicle manufacturers to say, well, okay, what is the type of architecture that I want to deploy that can help me, incorporate all of these safety capabilities? So I would agree. I think the architectural change driven by safety is absolutely huge at the moment.
And so, how would you say that Indie Semiconductor approaches this safety challenge?
Yeah. So if you look today, the key kind of areas for driver safety and road user safety actually are vision-based systems, so cameras, radars, ultrasonic for parking safety, and then LiDARs. So our approach really is to have a full portfolio of sensing for all of those areas. So if you look at vision, we have camera-based vision chips that will, address vision and sensing. So vision would be, surround view, e-mirrors, backup cameras. But sensing will be you're capturing the video. Are you processing it with compute vision and doing object detection? So can I see there's a pedestrian? Can I detect a particular road sign? Can I detect a cross-traffic event that's happening? So we're developing multiple chips that are focused on the vision space. If you look at radar, there's a kind of two big areas around radar. There's long range forward vision, so you can see that being used for adaptive automated emergency braking, for adaptive cruise control. Those systems typically use 70, 80 gigahertz radar. So we're developing solutions for that. In fact, we've won one of the top 4 tier 1 customers for our radar solution. But we're also seeing interior radar as well. So for occupant monitoring, vision is great for certain applications, but the resolution granularity of interior radar, and there we're talking about 120 gigahertz, you can actually do vital sign detection. So you can actually detect heartbeats and respiration inside the car. And we're developing solutions for that segment as well. Ultrasonic, sorry, go on.
Sorry, how is radar able to detect a heartbeat inside a car?
It uses the principle of Doppler shift. So because of the super fine resolution of radar, if there's, say, a baby in the car seat at the back, the radar waves have got the sensitivity to be able to detect those physiological changes that happen in humans and detect that.
You mean like changes, like the change in skin temperature, skin size and stuff as a result of? Oh, that's creepy. Yeah. That's really creepy.
From a safety perspective, it's really innovative.
It's amazing. And so, do you think a system like that could be used to, say, predict medical issues in a car before the accidents even happen? So, let's say you're driving along, you have a heart attack, but the car is still in motion. Do you think that could be used to try and anticipate those kind of things?
I'm not sure about that specifically, but I think vision-based solutions today already are looking at driver alertness. Are you looking, straight ahead? So, if your eyes are starting to get droopy, the car can initiate, safety actions as a result of that. But it's an interesting point. I'm not sure at this stage. I'm sure there's a lot of medical algorithmic research that can be done around that segment.
So it's interesting how, as technology becomes more integrated into cars and we have these systems that can detect accidents before they happen, it seems to be that we're taking the safety aspect out of human control, with the idea that generally speaking, humans are nowhere near as reliable as a system that can think faster, can see faster, hear faster, respond quicker, respond safely. And I think, would that be fair to say that we are taking safety away from humans?
I think my view is a little bit different. I think it's complementary today.
Complementing,
yeah. Because we as humans still have an extremely important role to play. I think fully automated driving is still some time out. Public acceptance
Definitely, yeah, definitely is
So
out.
I
Yeah.
see all of these systems as being assistive rather than in
Yeah.
sole control.
And so you could almost say that the car is becoming more of an extension of the human body, whereby, you know, your own, essentially your own senses are being heightened by the fact that the car can sense these things for you, give you feedback, and then you can then make a decision as to what to do.
I mean, in a way, it's giving you sensing superpowers, because if you look at something like
Mm.
LiDAR can see 200 meters ahead, right? So, human vision just won't have the acuity that you need.
Of
LiDAR is
course.
now targeting, detecting a tire 200 meters ahead on a highway, for example, and tires, what, I don't know, 15 centimeters high when
It's not very big,
laid
yeah.
down. So you need to be able to have that kind of sensing capability. So for sure, it's supporting the driver.
Hmm. And I think it's also important that, especially especially with motorways, the high speed that vehicles travel and the large stopping distance, the large thinking distance, every extra meter you're able to give to that driver is just, I think it's disproportionately. How do you say this? The degree of which you can respond is just disproportionate, such that if you can respond at 2 meters extra, it's a lot more than what you could stop in, if that kind of makes sense. It's a bit confusing.
Those kind of highway speeds, 60, 70, 80 miles per hour, the thinking time is compressed, right? So you need to be able to act quick.
Yeah.
And some of the perception algorithms that are now being developed to take in multi-sensor input to make better understanding of the scene in front of the vehicle, and to support the driver in making decisions or alerting to danger. It's quite phenomenal what's happening in the industry.
So we've looked at driver safety with automation and electrification, but in terms of trends, I think we're also looking at in-cabin user experiences. So could you dive into a bit about that as well? So we already covered about the fact that you can use inside radar to pick up life signs, but what other trends could you see in that space?
Yeah, and I think when you talk about in-cabin, people perhaps gravitate towards thinking about the in-vehicle infotainment unit, the big touch screen that you have that's controlling your audio system. But actually, the user experience is now becoming about much more than that. The trends that we've seen and that we're tackling are things like, how do I bring my favorite device into the vehicle? How do I interface it into the car? So, we're seeing things like, everyone's familiar with Apple CarPlay, Android Auto.
Yeah.
You're mirroring, you're transferring your capability from your device into the car. But also people need to be able to charge their devices as well. So USB power delivery, some of the power requirements for these systems now are growing. It's crazy. 60-watt USB power delivery is kind of typical today. The standards are evolving to support 120 watts, 240 watts, and you're like, what do I need?
I didn't even think that'd be possible down USB.
Well, people want to charge power tools, mobility scooters, camping gear.
Of course.
So the power requirements, and actually, power delivery is one of the unsung heroes of the in-cabin user experience. Actually, wireless charging now. Yes, USB is important. People are saying, well, I just want to be able to put my phone down in the cockpit and it just starts charging on a surface. So, a lot of activity around wireless charging that we're seeing there.
Unless you're an iPhone 15 user, in which case, if you've got a BMW, apparently their wireless chargers are breaking the iPhone 15s.
I did read that. I don't know the details of that.
Yes. I think what's happened, I'm not sure why, but I think what's going on is that the wireless chargers are essentially frying the NFC of the iPhone,
Right.
and so you can't use it for car payments afterwards. So I assume it must be a radio issue or I'm not sure what you call it. It must be not wireless. It's not radio. It's electromagnetic. So it must be I think it's an interference thing going on. But it is interesting to see how, like you say, it's not just because I think in the past anything inside the car was traditionally sort of centered around the media side, playing music and all that kind of stuff. But now we're really shifting to a new paradigm whereby it's actually more of an environment that you could almost live in. Essentially, you want to make sure that it's a livable environment. It's comfortable. It's got all the amenities that you need for your everyday use, especially with more electrical devices. But when it comes to integrating semiconductors into cars itself, obviously, Indie Semiconductor stands out as an automotive provider for semiconductors. But What are the biggest challenges that engineers in this industry face when using semiconductors in an automotive environment?
Yeah, there's multiple. And just to finish off the thread on the in-cabin, I mean, the other two big areas are lighting and small motor control. So lighting has
Mm,
become really critical. You'll see a lot of OEMs now are putting in very elegant lighting schemes into their cars. You see light pipes across the dash, across the door,
mm,
illuminating parts of the in-cabin. And then motor control, we all want convenience of our seats, our air conditioning, all of the different physical controls are now moving to use small motor control. And when you look at lighting, motor control, power delivery, these are now causing huge challenges around thermal considerations, electromagnetics,
mm,
physical form factor. So, whilst people might think about, all right, the sensing is hard enough as it is, for ADAS, but actually in cabin, some of these challenges around thermals and EMI are really big head scratchers for automotive designers today. So being able to pack in all of this electronics in a form factor that, when you get in the car, you don't see ugly bulges in the surfaces is really
yeah, of
difficult,
course.
really difficult. And so that's where we're seeing, our customers are saying to us, hey, we've got thermal limitations. Can you deliver
Mm,
very low power so we don't have to make compromise? Simple example, lighting. If the thermals start to run away, the lighting luminosity has to be ramped down because the LED just can't
mm,
cope with that thermal kind of condition. So then the user will notice that as a dimming of the lighting in the car. So no one wants that, right? You've set all your multicolor lighting capability up, and after about an hour's driving, the car decides, oh dear, everything's heating up. I've got to dim the lights down. So just having the feedback control, the LED driver control around that, again, sounds simple. It's actually really difficult.
mm,
Electromagnetics, right? A lot of these systems are using pulse width modulation control. If you
yeah.
don't look after the electromagnetic emissions properly, these systems start interfering with each other. So, this has become a real challenge that, you know, we as consumers want aesthetically pleasing interiors. Automotive designers are trying to juggle with, well, how do I make sure the form factor's low,
Mm.
the thermals are applicable, the power dissipation is not crazy. So I see there's some of the big challenges that we're seeing.
I think that's quite interesting about the lighting aspect, especially when it comes to electromagnetic interference. As you're saying, with pulse width modulation, it's a great way to reduce energy consumption and to control the brightness digitally. But the problem is, the moment you do that, you've got these sharp spikes of current going down wire, and then suddenly that can cause interference. Um, but what kind of interference does that usually cause, or what parts of the vehicle would you say are vulnerable to that type of EMI?
Yeah, I mean, it depends what kind of frequencies those EMI emissions are
Mm,
occurring at, right? So it could fall into the band of other sensitive chips. Anywhere there's an analog interface, there's an opportunity for unwanted emissions to find themselves into those kind of inputs. So, it's broad spectrum actually. Anywhere you've got sensors, they will be susceptible to that EMI radiation. So broadly across most of the vehicle actually.
and so by integrating and incorporating these new kind of lighting techniques with PWM controls, suddenly you're now putting at risk the safety features which are dependent on those sensors like the LiDAR, the ultrasonic sensors, etc. Essentially, you get to a point where you can't afford to trade the safety for style. Even though most people would like to have a very stylish vehicle, you have to make sure that it doesn't interfere with the safety part first, which is quite interesting because I never in my life would have thought that lighting would be an issue with regards to EMI.
Yeah, again, because you're talking about pulses, sharp rising edges,
Mm,
falling edges, right? They can create spurious emissions all over the spectrum. So, one of the things
mm,
we're acutely aware of is, we want our customers to be able to very rapidly design, deploy with our solution. So we actually take a very system-based approach to our products. We design the chip, yes, but we don't just give an evaluation board to a customer. We actually develop representative modules of what our customer might be designing themselves. And we do that EMI and thermal testing ourselves to make sure the recommended reference design that we have has already taken that into account, and that's quite, different in terms of semiconductor companies, that we're actually designing the modules, not because we're a module company, but we want to understand the problems that our customers are going to have before they actually start designing with the chip themselves.
Now that's quite interesting, because this is definitely a trend I'm seeing with more and more companies these days, which is that in the past, like you say, companies would be like, we've designed the chip, here's an evaluation board to test if you want to test it. But what you're really saying is that where Indie Semiconductors is trying to differentiate itself is that not only are you developing those chips, but then you're going to say, look, we actually know how to use them in your end product because we've seen these problems before with other customers. So here is a way that you can use it as not as an evaluation, but something that could actually be deployed in a real product. And would you say that's what you're trying to differentiate as a company?
Yeah, absolutely spot on. We've actually got a systems team that previously were working in a tier one automotive company. So they've had, the battle scars of dealing with chip companies just throwing over a chip and saying, here you go. So, again, we don't want to be a module company, but we want to be empathetic to the problems our customers are going to have. It's really a de-risking exercise. So rather than waiting months and months for them to design and tweak and iterate, we're saying, here's a great start point. We think it's reflective of what you might want to do in your application. And it just helps them de-risk their development cycle.
Now this actually raises an interesting question. Would it be fair to say, especially in the past, a lot of semiconductor companies who would produce automotive grade components were themselves not involved with the automotive design, so there was a bit of disconnect? So they said, here's a diode or whatever, or here's an FPGA for an automotive environment, but they themselves haven't really ever worked, in the same way that as some of your indie semiconductor engineers have actually built and designed vehicles. Would you say that would be fair to say?
I think broadly, if you look across the industry, I think that's generally been the historical case. And it's also, because traditionally the tier ones wanted to have full end-to-end control of their development. I think with all of this, the three big megatrends happening in automotive at the moment, development cycles are being compressed. So everyone in the value chain is looking to see how they can help their customer get to the end result quicker. So I think the expectation in the industry is changing, and those suppliers that have the capability, the expertise to be able to consider supporting their end customer in that speed up, I think they will be the winners longer term.
Now, in terms of the challenges that you've personally seen, what's the most interesting project that you yourself have seen while working at Indie Semiconductor?
Probably the LiDAR program that we're working on. So everyone's familiar with radar, familiar with cameras. I think LiDAR is the next kind of sensing power that we're going to see being integrated into vehicles. And again, all these sensors are complementary. We see a lot of debate in the industry. You only need camera, you only need radar. And for me,
I'm not going to mention names, but I think we both know who we might be talking about when somebody said that radar and LiDAR were completely unnecessary because humans can have eyes, so that's all you need. Which I think, from an engineering point of view, is not the best way to approach a vehicle with autonomous driving systems. But I think you're right. Karen,
I think our view is, there's no downside to leveraging the strengths of these different sensors, right? If you can make the technology performant and you can make it mass market deployable, then absolutely, there's absolutely no problem having redundancy of sensing capabilities. So I think the LiDAR program that we're working on is a phenomenal challenge. It brings together optics, it brings together signal processing, it brings together data capture, very high performance ADCs, DACs. It brings together low power requirements. It brings perception capability. So I think, when you look across the stakeholders that we're working with, for sure it's an absolute beast of a program. And, our view really on LiDAR, there's two kind of technologies people are talking about: direct detection, coherent detection. Our view very much is coherent detection is the way that the industry will go, kind of looking at how optical communications went, how radar went as well. Radar started pulsed comms and is now coherent detection based. So I'd say that's probably the biggest program that we're working on.
So could you explain a bit more about what coherent detection is?
Yeah, so if you look, direct detection is where you ping out a pulse, whether it's a radio pulse or an optical pulse, and you simply wait for it to come back, and you can infer the distance to the object by that round time of return. Coherent detection is you send out a signal, and when it comes back, you mix it with a copy of that original signal. So you coherently mix together those signals to detect a beat frequency. And that form of detection gives you much more range and granularity of detection.
And I suppose I'm trying to figure out why is that the case then? Why does it give you a better range?
So you get much better effective detection capability of the echo, if you like. You get optical gain when you look at the maths through it. You effectively get gain because when you mix the two signals together, you reject everything that isn't at the same frequency as you. So it has very good signal to noise ratio capability.
Oh, okay. I think that does actually make a bit of sense. So it's kind of okay. So you're only looking at signals that were specifically produced by your own device. And so does that mean that different LiDAR devices for different vehicles, would they use slightly different frequencies to try to provide some distinguishing
because
differentiation between them?
Because you're operating at a different end of the spectrum, you've got so many frequencies available. The chances of interfering with another LiDAR or getting interfered by solar radiation are absolutely tiny. So that's one of the benefits of coherent detection, actually, is its interference mitigation. If you have lots of cars deploying with a pulse-based LiDAR, eventually they will start interfering with each other because you don't know, was that me or someone else?
Because it would only take two cars parallel to each other on the motorway that both look at an object 200 meters down the line. If they're using a pulse system, they both detect the pulse and think, oh, I didn't send this, but maybe I did. Now it's really, really close suddenly, or maybe it's miles away.
That's why,
and so
yeah, sorry. That's why
that does make a lot of sense.
Radar in vehicles, it started with pulse-based detection, 20 years ago, and now it's moved to coherent detection for that reason.
That's really interesting. And when it comes to LiDAR modules, though, do manufacturers actually tune the frequency uniquely for every single module built, or is it kind of like an ID pattern that they all have that's changed so that every module is unique? Does it work like that?
I think they source their lasers at a given frequency, and they're very narrow line width lasers. And the chance of, just by the manufacturing variability of two lasers being on exactly the same frequency, given the spectrum that you've got available to you, is pretty low. So it ends up statistically being a very low probability.
And I'm pretty sure that they are infrared lasers, aren't they? The ones that LiDAR uses.
Yeah, very high frequency.
Yeah, and what powers do they have? Because I've always been curious about this.
Yeah, so it's we're talking about tens of milliwatts here. We've got very important eye safety concerns, and that's another important point about coherent detection. Because it's so selective, you don't have to pump out as much power as direct detection. Direct detection needs to use higher power, and then you're limited by eye safety, especially if you're operating in, say, 950 band. You want to make you've got strict regulation around, if someone happens to look head on into that LiDAR, you want to make sure you don't end up blinding, causing retinal damage.
And so you've got a 10 milliwatt laser which has been pulsed for a very short period of time using the coherent pattern. So overall, effectively, to the human eye, appears to just be obviously it's invisible as well. But in terms of like the what you'd say, I suppose, is the total delivered energy is so minute that even if it was a 1 watt IR laser, it would still be a very tiny amount of energy delivered in the first place.
Yeah. So for coherent, you're talking about a continuous wave, and it's generally frequency modulated continuous wave.
Oh, okay, I see. And so it's always pumping out the energy, but it's using that. Okay, I understand. Brilliant. What solutions would you say that? So what solutions are you offering today then for engineers in the automotive space, as well as the LiDAR systems that we were just talking about now?
Yeah, so it's basically the three kind of main segments that we spoke about in automotive. So for in-cabin user experience, we have USB power delivery, we have wireless charging, we have the lighting, driver controllers, we have external, so matrix lighting is becoming very popular for external lighting for headlamps. Motor control, so everything to control your seats, the various flaps in the car. And then I mentioned camera-based solutions, so for e-mirrors, for backup camera, for front sensing, for driver monitoring, occupant monitoring systems. Radar we talked about, so we have long range radar solution, internal very high frequency 120 gigahertz, 240 gigahertz radar. And then lastly, around electrification, that's a new big focus area for us actually. We're doing ASIL-D safety monitoring chips, we're doing battery management monitors, we're doing battery sensor hub monitors. So a whole big area across the vehicle actually. And I think probably looking at our semiconductor peers, we've probably got the broadest automotive portfolio across all of these different segments.
And I think that's quite important for an engineer, because when you're designing something as complicated as a vehicle, which I'm pretty sure have well over 1,000 semiconductors these days, you want to try and minimize the number of different suppliers that you have, and you want to make sure that everything's under one, it's kind of like one under one family. So if you can get most of your parts from one supplier, I think that's quite beneficial. So what you're essentially saying is that one advantage that engineers can have within the semiconductor is that because your portfolio is so broad, not only are engineers able to go to a company who has the automotive experience in producing semiconductors, but you've also got the biggest selection of choice, as well as covering most aspects of a vehicle. So an engineer can essentially take advantage of the Indie Semiconductor family, which provides a lot of convenience. Would that be right?
Yeah, absolutely. I mean, we want to be a one-stop shop for customers. Obviously, the products need to be competitive and stand on their own 2 feet to be selected. But, we're confident with kind of expertise that we've got. And, as you said, there's like thousands of semiconductor devices in the vehicle now. And if you look at an average car, there's $1,000 worth of semiconductor. That's just your average car today. If you look at a high-end, executive luxury car, you'll be talking about $3,000-$4,000 worth of semiconductors. So our goal is to take as much of that as we can.
Which is a pretty impressive number to think, actually. Even for a mainstream car, $1,000 of electronics, and that's when it's been mass produced as well. So we're not talking, I'm going to build my own car from scratch and I bought the parts individually. This is after you've bought reels, after you've bought. You've ordered PCBs in tens of thousands and you're installing them into vehicles, and there's still $1,000 per vehicle, which is honestly quite mind-blowing. So that seems to be a really major shift, actually.
And that's $1,000 just for the semiconductors, right? Not
just for the semiconductor, yes. Yeah, not even putting it together.
Exactly.
So So in terms of technologies that you guys are introducing or currently working on, is there anything you could tell us as sort of like a preview, something that maybe we could get a bit of a scoop on before anyone else?
Well, I think...
Ideally, hopefully.
Well, perhaps taking a little bit of a step back, in automotive, you hear a lot about central compute. The car will have a big chip that will be the master brains and control everything across the vehicle. And maybe for a future autonomous car, that's a nirvana that will happen one day. Our view actually is for mass market, for scalable vehicle platforms. And if you look at the big OEMs, they have everything from a city car at $10,000 all the way to a luxury car to $100,000, right? The same electronics architecture does not make sense across that broad portfolio of products. So one of the things that we're very passionate about is enabling distributed intelligence, as we call it, across the vehicle. So ensuring there's local decision making where it makes sense. So that means having not just the sensing, but processing where that sensor is. So, our view is there's going to be more and more sensors going into the vehicle. There's going to be more and more processing needed near the edge of the vehicle, rather than shipping all of this gigabytes of data to a central location, adding cost to the wiring, adding power consumption, because you're going to have really high level signaling. So we're focused on bringing distributed intelligence into the car, and part of that we see a fusion of sensing happening at the edge will be a big kind of evolution that will happen. And it's certainly something that we're starting to look more and more at as a future product focus.
Fantastic. Now, just before we wrap up this podcast, I've got one more question for you. For the engineers who are watching this video, if they want to get involved with Indie Semiconductor and the products that you offer, what would you recommend to do?
Yeah, we'd love to talk to people to see how we can help them with some of the challenges they're dealing with. Please visit our website, indiesemi.com. You'll find a lot of information there on our various product areas. And yeah, please reach out. We'd be happy to see how we can help you.
Well, it was an absolute pleasure having you on the podcast today. Thank you ever so much for joining us.
Thanks for your time today, Robin. It was a pleasure.